Is this okay sound? Yeah? All right, so I'm Brad. I live in Seattle, and I went to film school a really long time ago. And for Carter, wherever he is, I went to USC, so I went to school in the George Lucas building and heard way, way more about Star Wars than I ever want to know. I got my first job at an ad agency by lying and saying that I knew how to program. I got the job, and I started making games in Flash for ad agencies, for like movies and major brands. And then I went to work for startups, and I continue to do Flash. I did front-end applications for Genie, which is a collaborative family tree. And then we spun out Yammer, which is social networking for business. And I built the desktop app for that in Flash, unfortunately in Adobe Air. And now I'm here, and I'm here to tell you to quit your job and make art instead. I know that you're all JavaScript engineers. You have recruiters throwing money at you. Chris's 12-year-old had 3 job offers at lunch. So just forget about all that. And make art instead. Make something useless, because it might help you become a better engineer. Okay, so don't really quit. Although if you are looking to quit, let me know. I know some people that are probably hiring, and drop me a line. But give this a try. Give Creative Code a try. It's worked for me. So I want to show you a project that I did. My wife is a poet, and she teaches at UW, and we wanted to make a project together. So we created a book. It's an augmented reality book of poetry. And if you open it up, you'll see that there are no words, just a bunch of these silly-looking markers. And then the instructions to find the words, you have to go to a website. And when you show the book to your webcam, the text appears. And then you read the book in conjunction with your webcam, and the text actually lives in kind of a space in between page and screen. It's a little bit too much light for... And unfortunately, this runs Flash. Sorry. But now with this fancy WebRTC stuff, we can maybe port this to doing all JavaScript. So this has been a really fun project, and it's helped me professionally. We've been able to go, it was in the Library of Congress, in the French National Library. It's helped me professionally, not because a lot of people are buying augmented reality books of poetry. Although I like to think that this is the best-selling augmented reality book of poetry in the entire history of the world. And so what I learned professionally, I learned new skills. I learned about 3D. I knew a little bit about 3D before, but I learned really to get that interface, and I'm sorry I didn't demo it as well as Amaranth does, to get that interface to really work, it needs to match up so that you really feel like you're holding the words in your hands. So that required a lot of fine-tuning with 3D. And that's also learning about augmented reality. It also gave me this incredible obsession with frame rate. That thing needs to run at least 30 frames per second so that it feels like you're holding the words in your hands. And when you're obsessed with frame rate, that means that you're really obsessed with performance and exactly what you're doing in every tick of the application. And then probably the most important thing, because right now I do freelance helping people figure out how their product works and do user interface. This gave me a completely different perspective on interfaces. No one has ever seen a book like this before. So when we're doing a show at the Library of Congress and there are a bunch of old gray-haired ladies that are trying to read this book, their brains are blown. And thinking about how to explain how to use something like this to someone that's never seen something like that is a really good experience, a good lesson in empathy. And I think you can take that empathy to when you make a web interface. Nobody's seen that before either. So what can you learn doing Creative Code and trying new things is a way to kind of expand how people approach your interfaces. So why Creative Code? Most web dev, at the base of it, is just moving text around. Users create text, they save it to your database, other users read the text, maybe they write their own text. If you get people to do that, if you get 100 million people to do that 1 billion times, you've got Twitter and you've got a really valuable property. But it's kind of a fundamentally bounded set of problems. So if you do creative code, you get to try all sorts of new things. So don't quit your job, but maybe take a day off to try this. One important thing to remember, I know the title is Make Art, and that's a really freighted term. Don't think about it like art. Just think about it as experiments. And experiments mean it's not going to work in IE. It might not even work on Windows. And it might not even work without you having to go into your browser and turn some stuff on. And then, even with all that, you still might need some expensive hardware. You might need a really nice laptop, or you might need some external device that only you have. But that's okay, because it's an experiment and you're just doing it to learn. So if I were to try and define what creative code, or at least how I'm talking about it, it's an experiment with the goal of surprising and delighting. And surprise and delight is kind of an interesting or an important idea to me. When the words first showed up from the screen, there was a little bit of a gasp. Like, it's a surprising thing. You haven't seen it before. It's surprising and delightful. And Ranth and I got really lucky that we found something in our experiments that actually felt that surprise and delight. And I think that if you aim for that as the goal of your experiments, you can have a lot of fun. So this is the road plan. When I left Genie 2 years ago, and that was after spending 6 years doing ActionScript. I was really good at ActionScript. But we all know that Flash is not the future. So I wanted to look at JavaScript as, can I do stuff in JavaScript? And I found out it's pretty good. JS engines, they're gosh darn fast now. Modern browsers, you have Canvas, SVG, and the CSS3, which really gives you pretty good places to put graphics. I don't know what the technical term for moderner browsers are, but WEBGL and WebRTC actually gives you access to the hardware on the box, which means you can do even more amazing things. And then all these super geniuses out there have made these libraries that let you do graphics, physics, 3D, particles, that make using all this new stuff really easy. And then finally, one of the most interesting things is that we're in a renaissance of input devices. We have the Kinect, the Leap, the Oculus Rift, and the Arduino, and they let you do just amazing things. And they all talk to JavaScript. So JavaScript platform is ubiquitous, fast, and powerful. And that's for creative code, but it obviously applies for the web in general. And I think that's a big reason why JavaScript is eating so much of software development, because it's just hard to beat. There are other platforms. I don't want to be remiss. If you are interested in doing creative code, there's obviously Flash. You're going to have trouble finding work with that. Processing is the granddaddy of creative code. It came out of the MIT Media Lab, and it was aimed at kind of bridging design and engineering. And it's a lovely system. There's processing.js, which implements it in JavaScript. And then these other two, Open Frameworks and Cinder, are really good for doing museum-level installation art, like where you're doing hundreds of cameras, lots of really super-duper amazing stuff. If you go to either of those websites, Open Frameworks or Cinder, there'll just be amazing things that people are making with it. Unfortunately, it's C++, and that's really, really hard. So how do you make pretty pictures in JavaScript? The first fundamental debate that probably all of you are aware of is Canvas versus SVG. And I know it's a diverse crowd, so I'll briefly cover the differences and then get on to how it can make neat stuff. So Canvas writes pixels. And the advantage of that is that it's extremely fast. The disadvantage is that the DOM has no idea what's going on inside the block of the canvas. So if you imagine that this is a canvas, the white and black is a canvas object. I told the browser through JavaScript to draw a black square in the middle of it. The DOM has no idea. It's just a big square. So I can very quickly draw that box, but I can't do anything with it. The alternative is SVG, which writes vectors. Vectors are very DOM-friendly. They're, I assume, first-class citizens. You can target them, you can style them, they can listen to clicks. The disadvantage is that your document is constrained by the number of elements. The same as if you have a really complicated HTML page with a whole ton of divs in it, it's not going to run as fast. So if you really want to do something with a whole bunch of items on screen that you're animating and being interactive, SVG is going to bog down. D3, which you probably have all run across in demos on Hacker News, writes pure SVG, and you can do really great things with it. So SVG the browser thinks of this as two squares. It actually knows that there's a black square in the middle of it, and that if you click on it, it's different from clicking on the white square. So there's a hybrid solution, which are canvas libraries, and they provide like an SVG level abstraction on top of canvas. JavaScript knows about the objects, but not the DOM. So JavaScript is writing objects to the canvas very quickly, and it can manage where when you click on the canvas, it knows which object you clicked on, but the DOM still has no idea. Paper.js, Easel, and many others there are a lot of libraries for this. Paper.js, I think, is particularly elegant. So in this case, this is actually a canvas object, but if I clicked on the black object, JavaScript would know, like, hey, you clicked on that square and do whatever fancy thing you want to do. So why am I talking about performance all the time? We're looking for surprise and delight. So people generally respond better to more things animating and lots of stuff going on. So I have a little demo about that. This is Paper.js, and we're animating 100 little circles. It's a very sophisticated animation. And it's just moving them one after the other. And it's running pretty well. This is 60 frames per second. So let's improve that to 500 frames per second. And it's slower. We're running 20 frames per second, but it's still passable. So if you're thinking about making something with Paper.js, you'd be like, I think I could put up to 500 particles on screen at a time and still have kind of an experience that might surprise and delight people. And then if I wanted to really like test it and put something like 10,000, it's not moving very fast. It's doing 1 frame per second. And this isn't really a way to get surprise and delight. There's nothing really worse than an experience that's really, really slow. So when you're building apps, you have to think about, like, you have this sort of CPU processor poker about like what you can put on screen and what you can move around. And if any of you have built games, this is a pretty common part of the economics of making a game. Yes, I want to leave. But there's this other thing. It's called WEBGL. WEBGL, this is 120,000 particles. And it has no problem running it at all. It's interactive. I can fly around the space. And as you see in the upper left with that stats bar, it's running it at 60 frames per second. It's just as fast. It could go faster. It's an incredible, if you're looking for surprise and delight, this is amazing. So Canvas versus SVG versus WebGL, the reason why the conversation is always Canvas versus SVG is that browsers actually support them almost 100%. I'm sure that there are some rules that you guys are more expert in than I am, but they're pretty broadly supported. And WebGL is something that more like 50% with a lot of asterisks next to them. But that doesn't matter for our purposes. Remember, it's an experiment. It doesn't have to work on IE. WebGL is great. It also requires a radically different way of drawing objects, but it's a magnitudes faster for the right application. And I think that this is an object lesson in why doing creative code is an interesting experience. This is something that you could not consider for your production website, but if you look outside the box, maybe you see something that's really kind of an interesting solution that you can make work for what you're doing. So there are a bunch of libraries that I would love to demo, but there's just not time. So that website has a list of some of the ones that I put together when I was putting together this talk. And then this is a set of a bunch of great sites that people are doing with creative code in JavaScript. Mr. Doob, as maybe some of you have seen, he created 3JS. He was a great Flash 3D artist. and now is switching to do JavaScript, and I believe works at Google. He and Aaron Kobler have done a lot of really great projects. Okay, so moving right along, to create this surprise and delight, you need to get the user involved. When you see demos, they mostly kind of unfurl at their own speed, and it's just something that provides a visual delight, but you can't really do much to it. So you want to get the user involved. There's always a mouse, but after 20 years of clicking around on the internet, is there anything new that you haven't clicked on yet? It's a little harder. So if you're looking for surprise and delight, you think about touch. I think that what the iPhone did spectacularly when it launched was that it brought touch into the user experience. There were other touch screens before, but you didn't feel like you were actually interacting with the screen with your fingers in the way that you did with the first iPhone. It's a little hard to do touch on a desktop app, but there's no reason why you can't do something on mobile. Creative Code with JavaScript. JavaScript runs on mobile devices, I understand. There's also now the webcam. With this fancy WebRTC stuff, JavaScript can finally talk to the webcam. And that's really cool. So this is a project that does facial recognition and then uses my head as a controller. So it does a little parallax. This is a poor man's Oculus Rift. But it could be really fun if you do an interface. Like, what if you had things approaching your head and you had to duck? There's a lot of cool stuff that you can do with this as a thing. The great thing about webcams is that they're on every computer. So you're not really asking for too much for the user if you ask them to use their webcam. There's a little bit of cheesiness of like the Lightroom from, is that what it's called? The Apple app where you can like do funny things with your picture. But I think there's a lot of fun things you can do with the webcam because people like to look at themselves. And so webcam is definitely ubiquitous. It's on almost every device. But we also have all that external hardware that we talked about, the Arduino, Kinect, Oculus, and Leap. And today, I want to talk about the Leap. So the Leap is really cool. It's here. It's quite small. And it detects hands and finger position. And in that device, it has 2 little cameras and 3 infrared LEDs. It projects a hemisphere of like magic LEDs above the device. It does some really fancy math on it. I don't know how that worked. This is the genius level stuff that made the Leap the Leap. And then it returns to JavaScript or whatever scripting language you're using, the actual positions of the hand palms and what they call pointables in that hemisphere. It started shipping in July, and it's only $80. So to connect it to JavaScript, it's really pretty easy. It installs like you're installing a mouse driver, and sits persistently in your tray. I don't know if this is called a tray application, but that little green bar is the Leap, and it's green because it says I'm here and plugged in. And then they give you a JavaScript SDK to connect to it. And so to wire it up, it's actually quite easy. You just include the library, and then you create a new controller. And so controller new Leap. Sorry, this is CoffeeScript. I say enable gestures, and then the important part here is that it gives me a loop, and that loop comes with a frame, and the frame is all that fancy data that the PhDs figured out for me with this device. And then it broadcasts other standard sort of events that you can use to bootstrap your application when the Leap is ready. If it has a neat thing like if it detects smudges or too much bright light, so you can manage all that. The frame that comes in that loop is a lot of data. And it's not only is it a lot of data, it can come up to 90 frames per second. And what's included in it is hands. It has their direction. It kind of gives you a sense of it considers them spheres. and you can get an idea of the XY coordinate and direction orientation. And then it goes on and on, the pointables, which is a delightful euphemism. They call it pointables because you can use a pencil or anything else that's pointable. And it kind of goes on. This is actually the simplified version of it. It's a lot of data. So enough of that. We're going to see if it works, which is always stressful. Hey, ooh. Hey, so there are my fingers. And I'm using Three.js. What the app is reading the tick on every frame and identifying my finger positions. And then I'm drawing little 3D objects 60 times a second, exactly where my fingers are. And you can see that sometimes I lose fingers. It's not perfect. And actually sometimes it's doing a pretty good job here, but sometimes you get extra fingers, and sometimes extra hands come in, and it's really weird. So, this isn't like Minority Report, if you were hoping for it. But it's pretty good, and it's pretty cool. It gives us a lot of information that we can play with. So, how do we start doing something with that? The Leap guys, I don't know this, but I think they didn't operate under the assumption that it's going to be offering 90 frames per second of exactly precise finger position for just 10 fingers and just 2 hands. So they give you some tools that kind of let you infer things over time. This is a neat thing, something that Rick Waldron in his talk last year about the node bots mentioned that stuck with me. I wasn't here, but I watched the video. Is that hardware devices happen in real time. You can't, reality doesn't slow down because your app is going slower. So when you're dealing with this sort of high bandwidth interaction, you need to be able to deal with motion over time. And that's talked about in gestures, and you kind of have to get an idea of what the user's doing to interpret all this data. So they give you a few helpers that this is the scale factor is a handy one. And what the mechanism that they use is that you give them a frame from the past. So I cache in this app the last 30 frames, so about the last 30 to 60 frames, about the last second. And then I say, hey, Leap, how much has Brad's fingers changed from 10 frames ago? And if I pass that to scale factor, it'll be it looks like it's getting bigger, or it looks like it's getting smaller, and gives you that number. And then it does the same thing for translation, which is a linear action, and a rotation angle. And these are a little ambiguous in the documentation. They don't go into a lot of rules about how they figure that out. It's kind of up to you. But it lets you do broad sweeping things that are kind of fun. So here's a little continuing demo with scale factor. Exciting, right? So what I have, it's not behaving very well, but I'm actually controlling this little particle storm with my gestures. As I expand, the cloud gets bigger, and as I contract, it should shrink down. And it's still running at 60 frames per second because the WebGL is so fast, it gives me so much headroom that I can do the processing from the Leap and all these graphics and still have more room to do neat stuff. That's working a little better that way. It's kind of fun to play with. I don't know how fun it is to watch, but fun to play with. So that gives you a little bit of a sense of how you control the Leap over time. But there's no mouse, right? So how do I actually tell the Leap what I want to do? This is an awkward problem with all these innovative input devices. You'll see with the Kinect, I'm sure that you've all played Kinect games, they solve this problem with poses. You have to hold your hand up in a certain spot, and then they'll have a little burn down before that counts as a click. Google, with the glass, has OK Glass. And that's a way of signaling to the device, like, I'm ready to go. The mouse is actually a really elegant device. It gives you very clear intent at a very clear point, XY point. And unfortunately, when we move beyond that, there are a lot of neat things that you can do, but there's some problems. So you have to design around these limitations. The leap gives you a few gestures, a circle, a swipe, a screen tap, and a key tap. And you can cache them. You put a listener on the controller for gesture. I had hoped, when I read about this, that it simply would broadcast an event to say, user swiped, and you're good. It's like receiving a click. Unfortunately, it doesn't work that way. They simply tell you, user is probably swiping now, has been swiping, and you could get like 500 frames of the user swiping. And it's up to you to kind of figure out, was that an intentional swipe? What's going on? So I did a little bit of rules, and you see it's kind of fuzzy in the app when I demo it. You can identify a gesture by swipe. The state, it does tell you whether it's start, update, or complete, stop. The stop thing was a little dodgy. It tells you how long the gesture's been going on, and then the distance. And I keep track of the gestures in a little lookup table so that I can tell that if I've already acted on that gesture. And then I clean that up. Because that would be a horrible memory leak of tracking thousands of gestures in an ever-growing hash. So let's see how that works. OK, so I got that. And now, if I swipe, I can change the colors. This goes from black and white, which I guess is a little hard to see on that screen. But this halftone pattern, that's my swipe effect. And then when I swipe again, it goes to color. There you go. So I can see that this could be a game where you're kind of traveling through some space and you have this thing to expand and contract. And maybe something fun happens. I have you can try that out. This is a quick demo that I called Magic Fingers. I put up the repo. I'm not particularly proud of this code. I have a project that I'm working on to follow up between page and screen with the leap, where you'll stand in front of text and interact with it in kind of a subtle way where the text erases in front of you. I was originally going to demo that, but it wasn't quite as exciting, so you got Magic Fingers instead. Surprise. So takeaways from the leap. First is performance is really important, like in between page and screen. You really need to focus on what you're doing in every tick and how much you can accomplish. The headroom of WebGL is so fast that there are a lot of things that you can do. I'd love to combine an app like that with the parallax head view so that as you're dragging through the space, you can actually look around it. And that would be combining the webcam and a whole other library that would be looking for facial recognition. And to be able to do all of that, that would be asking a lot for the CPU. Another thing that's important about these sort of rich interactions is that there are many atomic actions. If you have a web-based app where the user's clicking maybe a shopping cart, a configurator, a user could spend maybe 10 minutes on an interface, which would be a long time, without a page reload. And maybe they're clicking 50, 60 times. Maybe you have 100 atomic actions on your interface. Here, we're having 60 to 90 interactions every second. So in a 10-minute session, or even a 5-minute session, we can get into the hundreds of thousands of atomic actions. So that means that there's a lot of opportunity for memory leaks. You need to be careful about wherever you're creating new objects, making sure that you're destroying them, making sure that you're unsetting listeners. You get to be really zealous about that. And when you fold that back into your regular practice of making apps, you're bringing those best practices forward as like a first citizen, makes your apps run a lot better. Another thing that's important to think about with these apps is a control event flow. There are two different libraries that are interacting, the Leap and the Three.js, the 3D system. They both want to have their own timeline. They both want to say like, hey, I'm important right now. And neither of them are important. The interface is what's important. And it's really easy when you're building an app, kind of the naive implementation, is to let every module, if you say that you're building a backbone app, the naive implementation is to let every app just like talk, every module talk to the interface whenever it wants. And that gets a problem where you have multiple modals on screen, or the user's focused on one task and something else is happening. So if you think about like having some structure that controls your event flow, that can make your app much more agile, nimble. Another takeaway here is interface problem solving. There's no click, there's no mouse. So how do you solve that? And you can't just duplicate a mouse. Maybe you have to do something else, or even design an app that doesn't need to have clicks. And the final lesson really for creative code in general, is that it's good for abstraction. I think that abstraction is one of the most important skills of an engineer, and it's what separates a good engineer from a great engineer. Being able to look at a problem and solve it with 2 amazing lines and some wicked regex. That's something that is a rare skill, and it's something that you can develop by maybe looking at problems differently. All right, we're reaching the end. So how to get started? You could try the libraries that I put up at WholePixel. Experiment with the webcam. I'd love to see people using a webcam. You can buy a Leap. It's only $80. And really, of the devices, this is the easiest to get started with. The Kinect is quite difficult. It's easier now that they've opened up the SDK, but the hardest thing about working with the Kinect versus the Leap, when you're working with the Leap, you can just do this. When you work with the Kinect, you have to type the code, and then try and look at what the report is. It's slow going. So buy a Leap, or here's your unexpected art lesson for today. Conceptual art. There was an artist called Saul LeWitt. He is the founder of conceptual art and minimalism. And he has all this great, it's called instructional art, that are drawings that are meant to be put on a wall. And all he provides for it are the instructions, and someone else is meant to do the work. So here's an instruction. On a wall, any continuous stretch of wall, using a hard pencil, place 50 points at random. The points should be evenly distributed over the area of the wall. All of the points should be connected by straight lines. That's the art. And then you hire contractors to come out and actually execute the art. In this case, they're Saul LeWitt certified draftsmen. So they are coming out and installing this either in a museum or in someone's home. There's the finished piece. They're actually quite lovely to look at. If you're ever, Mass MoCA has a bunch of them. Definitely, if you're ever in Western Massachusetts, please do go and see Mass MoCA. And then since you had the draftsman, you actually get a certificate saying that this is an official piece of art from Saul LeWitt. And they still do this. I don't know how they do this thing. He died like 5 years ago. So I don't know if they still do the signature. But basically, you could have an official piece of art from the artist that you never even met the artist. Because under this rubric, conceptual art, the art is in the instruction. So when I see instructions like this, and it might be just because I am who I am and not normal, I kind of feel like it could be like a ticket, right? So if you saw this in Pivotal, you'd be like, oh, so like this weird PM wants me to do this. And I think that because they're all, they're very specific, they're wonderfully ambiguous, but they're all specific with numbers and rules, they can be implemented programmatically pretty easily. Or like a hour per instruction. So I made a repo called Solving Saul. And you'll see that there are all the instructions. There's folders for each one, and a little bit of instruction on the repo. And you can try it with paper, D3 processing. You could link to a fiddle. I don't know if this will work, but I think it's kind of fun. And it's a way to get started. So better solve Sol. And take a day off. Try something new. And maybe you'll discover something that's really going to help you. Thank you. And please do let me know if you make anything.